In this video, I'll be introducing exponentials and how to solve three variable linear systems. Now that might sound complicated, and for the sixth graders, it might be a little too complicated, but first, let's do exponentials. So, say every year, the population of rabbits doubles. Okay? In this year, they have 10 rabbits. Okay? So they quite literally multiply. Okay, how would I model this? Well, let's map out an input and output table. This is our time t in years, and this is our number of rabbits. Okay? So, in the 0th year, right? In the 0th year, right when we start, there's 10 rabbits. After the first year, it doubles and we get 20 rabbits. After the second year, it doubles again and we get 40 rabbits. 3 years, we get 80 rabbits. Then, fourth year, we get 160 rabbits, and so on. How can I model this without just doubling it in my head, right? What if I wanted to know what happened, how many rabbits in the 10th year? Right? Okay, so what you can do to figure this out is notice that this is going to be 10 times 2, right? So we do 10 times 2 for the first year, times 2 for the second year, times 2, and we're doing that t times, right? So every year, we multiply it by 2, right? And we start off with 10 and we multiply it by 2 for every year, because it doubles every year, okay? Well, by the definition of the exponent, that's going to be 10 times 2 to the t. So, on the 10th year, that's going to be 10 times 2 to the 10, which is actually going to be 10 times 1024, which is going to be 10,240. I figured it out, and I didn't have to write out 10 different values, okay? So, if instead I had it that every year an oil tanker loses a third of its current load of oil. Okay? Right? And it has 108,000 to begin with. Okay? So let's write out the table again, right? So this is our time in t years, and this is going to be our amount of oil in the amount of oil left. Okay? So at t equals 0, it has 108,000. At t equals 1, it's going to have 108,000 divided by 3 is going to be 36,000, right? After another one, we divide this by 3 and we get 13,000. Okay, you can continue that on. And it's the same logic here. I start off with 108,000. First year, I multiply it by a third. Second year, I multiply it by a third. And every year, I multiply it by a third till I multiply it by a third t times. But that gives us 108,000 times 1/3 to the t. Okay, and that's how you do exponentials. Okay, so that's a pretty important one. But here's another one. If I have it that x plus y is 14, x plus z is 12, and y plus z is 22. I believe this is the problem. I don't know. Okay, how can I solve for x, y, and z? Well, I'm going to look at these two equations, right? Now, do realize that x, y, and z are all just numbers. They're just variables. They're substitute for numbers. So I'm going to have x plus z equals... Oh, sorry, I have these switched. Okay, so I have x plus z equals 14 and x plus y is 12, right? Again, these are numbers. So what if I were to do x plus z minus, like x plus z as a number, minus x plus y as a number, right? Well, I know what x plus z is. It's 14. And I know what x plus y is. It's 12. Right? So I get 2. Because 14 minus 12, I substituted in for these two. Then I get 2 at the other end. So let's distribute. There's like an imaginary negative 1 right there. Plus. So I get x plus z plus distribute the negative 1. X's cancel out. That's still equal to 2. And then I get z minus y equals 2. Okay? Or in other words, z equals 2 plus y, adding y to both sides. Right? These are just numbers. Right? You could also imagine this as y equals 2 plus x, but with different variables. Okay? Okay, so now I know what z is. Right there, I have an equation that has y and z in it, right? Let's plug in z. So y plus z equals 22, right? But z is 2 plus y. So let's substitute that in. Y plus 2 plus y equals 22. Right? Then you get y plus 2 equals 22, right? Okay, so I get 2y equals 20, subtracting the 2 from both sides and simplifying the y's, and then y equals 10, right? Oh, but I know what z is. It's 2 plus y, so z is 12, right? 2 plus 10. Should write that. 2 plus 10, substituting in for y, and I get 12. Okay? Also, I know that x plus y is 12, so I know that x plus 10 is 12, or x is equal to 2. So that's it. That's my solution. X is equal to 2, y is 10, and z is 12. So let's maybe do another example. So let's do 2x plus y equals 10. 3x minus z equals 9. And then y plus z equals 8. This probably won't work out well. Okay, so right here, I see something very special, right? There's a z and there's a minus z. So what I'm going to do is I'm going to add these two together. Right? That, I know what 3x minus z is, it's 9. I know what y plus z is, it's 8. That gives me 17, right? You can imagine also adding the two equations together. You can see the minus z and the z cancel, and I get 3x plus y equals 17, or that y equals 17 minus 3x, right? Oh, but look at right there. 2x plus y is 10. I have 17 minus 3x, so I can substitute that into y, right? So I get 2x plus 17 minus 3x equals 10. Okay, then I get 2x minus 3x plus 17 equals 10, or that negative x equals negative 7, right? Because I did 2x minus 3x is negative x. 17 subtracted over, right? Or that x is 7. Okay? Now I know what y is. It's going to be 17 minus 3x. So what's 17 minus 3 times 7? That's going to be 17 minus 21. What's 17 minus 21? Well, it's going to be negative 4. Negative 4. Okay? Now z, I know that y plus z is equal to 8, right? But I know what y is. It's negative 4. So negative 4 plus z is going to be 8. Okay? Then z is equal to 12. So z is 12. Right here. So y is negative 4, z is 12, and x is 7. That's the solution to that system of equations. If this doesn't make sense, I might make another video.